Get ready for a cosmic event of potentially catastrophic proportions. The red supergiant star Betelgeuse is sending out mysterious and alarming signals across space. Astronomers, utilizing the powerful James Webb Space Telescope, have made a startling discovery about this immense celestial body. Physicist Brian Cox has issued a serious warning regarding Betelgeuse's recent behavior. The looming question is whether we are on the verge of witnessing a supernova explosion so massive that it could permanently alter the night sky. In the vast expanse of the universe, stars are born, live, and die in spectacular ways. Among these, stars Betelgeuse has recently drawn significant attention from both scientists and the general public. Located in the constellation Orion, Betelgeuse is a red supergiant, one of the largest and oldest stars visible to the naked eye. Its reddish hue and fluctuating brightness have long intrigued observers, but recent developments have raised new concerns and sparked renewed interest. As we continue to study Betelgeuse, we may be standing on the threshold of a monumental event in its life cycle. But what exactly do these changes signify? Could we be witnessing the prelude to a cosmic event of unprecedented scale? Betelgeuse is a colossal stellar entity, around 900 times larger than our Sun. To put its size in perspective, if Betelgeuse were to replace our Sun, its surface would extend beyond Mars' orbit, engulfing Mercury, Venus, Earth, and Mars. This sheer magnitude speaks to the advanced stage of its stellar evolution. As a red supergiant, Betelgeuse is nearing the end of its life, currently in a phase where it expands and cools after having exhausted the hydrogen in its core and begun fusing helium. The star is estimated to be between 8 and 8.5 million years old, having undergone dramatic changes to reach its current state. Supergiant stars like Betelgeuse evolve dramatically due to the intense forces of nuclear fusion and gravitational pressure. What makes Betelgeuse especially fascinating at this stage is its red color, which stems from its relatively cooler surface temperature compared to stars like our Sun. While the Sun's surface temperature is about 5,500 Kelvin, Betelgeuse's is around 3,500 Kelvin. This lower temperature means the star emits light at longer wavelengths, giving it its distinct red appearance. This coloration is not merely cosmetic, it provides critical insights into the physical state of the star and the processes occurring within its vast gaseous envelope. Interestingly, Betelgeuse's color has not remained constant throughout history. Records from the Roman and Chinese eras suggest that the star appeared yellow roughly 2,000 years ago. By the 9th century, Arab astronomers described it as red. These historical observations underscore how Betelgeuse has changed over time, offering further evidence of its dynamic nature. Another key feature of Betelgeuse is its status as a variable star. Its brightness changes over time. This variability has captivated scientists and stargazers for centuries. The star undergoes a brightening cycle roughly every 400 days, along with a longer cycle lasting about 5 years. As early as 1836, astronomer Sir John Herschel documented these cycles, and even Aboriginal stories may reference this variability. What sets Betelgeuse apart is not just that it brightens and dims, but the irregularity of these fluctuations. Unlike many stars that follow predictable patterns, Betelgeuse occasionally deviates, hinting at complex, less understood internal processes. In late 2019, Betelgeuse underwent a significant and unexpected dimming event, now referred to as the Great Dimming. As one of the brightest stars in the night sky and a key feature of Orion, its sudden change caught the attention of astronomers worldwide. The star's brightness decreased at a rate of approximately 0.01 magnitude per day. By February 2020, it had dimmed to its faintest recorded level. Normally visible even in light-polluted skies, Betelgeuse became noticeably fainter, prompting speculation and concern. However, interpreting these changes is complicated by the time it takes for light from Betelgeuse to reach Earth, about 654 years. This means we see the star as it was over 6 centuries ago, which makes real-time observation and prediction extremely challenging. The Great Dimming served as a stark reminder of the limitations we face in observing the cosmos and highlighted just how little we still understand about these distant giants. Andrea Dupree, Deputy Director of the Harvard-Smithsonian Center for Astrophysics, led a 3-year study examining the dramatic changes in Betelgeuse's outer atmosphere using the Hubble Space Telescope. The research provided groundbreaking insights into how variable stars behave. These stars regularly expand and contract, causing changes in brightness. Thanks to Hubble's sensitivity to ultraviolet light, scientists were able to observe heated layers on Betelgeuse's surface influenced by massive convective cells. Spectroscopic data from Hubble in 2019 and 2020 allowed scientists to measure the speed of material moving through Betelgeuse's upper atmosphere. They found that gas was being ejected from the star's surface at speeds of up to 200,000 miles per hour, reaching distances millions of miles away. This movement contributed to the formation of a dense dust cloud, which in turn caused the observed dimming that lasted for 3 months. Dupree and her team believe that a significant mass, possibly twice the usual amount, was ejected from Betelgeuse's southern hemisphere during this event. This unusually rapid mass loss raised questions about whether it could signal an impending supernova. Although Betelgeuse is located 654 light-years from Earth, any explosion it undergoes would be visible to the naked eye and offer a once-in-a-lifetime opportunity to observe a supernova up close. Still, the core mystery remains. Is this a precursor to a supernova, or simply another chapter in the long and turbulent life of this massive star? Multiple theories have been put forward to explain the rapid changes observed in Betelgeuse, but much remains uncertain. As scientists continue to analyze the data, we are left to wonder, are we standing on the edge of witnessing one of the most magnificent events in modern astronomy? What do you think about the possibility of seeing a supernova in our lifetime?